Hello, let's talk about component form and magnitude of a vector. So first, a vector is a quantity with both magnitude and direction. To differentiate vectors from variables, constants, and imaginary numbers, vectors are denoted by a lowercase bold-faced variable or a variable with a harpoon arrow above it. Okay, so you usually have that harpoon arrow above it. So here's two examples of two different vectors. The vector v is represented by the directed line segment RS. And I apologize, this is supposed to be over. Let's draw it over. Oops. And has the initial point at R and a terminal point at S. Vectors are often represented in component form. Vector v in figure 1, which is right here, has an initial point at the origin. And again, oops, wrong way. See, R is at the origin. And is said to be in standard position. Okay, so vectors that have an initial point at the origin are said to be in standard position. A vector in standard position can be represented by the coordinates of its terminal point, and we'll talk about that a little bit later. Thus, vector v in component form of v1, v2. Notice that the brackets surrounding the vector components v1 and v2 are pointed, not round like parentheses. So they do that so that you don't confuse them with coordinate points. All right. So the magnitude of v, or rs, is represented by these two lines here, or here. And it's calculated using the distance formula. So magnitude is the length of a vector, okay? So this is actually supposed to be here. So the magnitude is equal to v1, and this is supposed to be squared, plus v2 squared. The component form of a directed line segment is basically just taking the terminal point and subtracting it from the initial point. So here we have the terminal subtracted from the initial for the first variables, and the terminal point subtracted from the initial for the second variables, and that gives us our vector u. The magnitude of a directed line segment is basically the exact same thing, except I'm going to square that line. This is supposed to be a square to square it. So let's do some examples, or an example. It says find the component form and magnitude of vector u. So if you recall, is this? I believe, yep, this is vector u. Okay, so we're going to take the terminal point and subtract it from our initial point. So we'll have u is equal to, again, our terminal point, which is -4 minus -2, comma. So these are our first values, and then our second value, our terminal point, which is 4 minus 2. And so -4 minus a -2, which is -4 plus 2, which gives me -2. And 4 minus 2 is 2. So here's the component form of vector u. The magnitude of vector u, remember we said we're just going to, and it's just basically the distance. And as you probably recall, this is the distance formula that we're using because I've taken 2 points, subtracted them, and I'm going to square them now. So I am going to get u1, which is -2, squared plus u2, which is 2 squared. That gives me 4 plus 4, which is 8. So the distance or the magnitude of vector u is 8. All right, let's do another one. It says find the component form and the magnitude of vector v in standard position. So we're going to use the actual formula for finding it. However, remember that the actual definition told us that if it's in standard position, then the actual component form is that terminal point, right? So again, have vector v is equal to, and then I have my terminal point, which is 8, minus my origin, right, which is 0, 0, which is my initial point when it's in standard position. So this is the initial point. So minus 0. Then I have -2 minus 0. And that just gives us what we started off with. So I have 8 and -2. So there's my component form of vector u. Now to find the magnitude of vector v, which is just the distance, and it's really just the distance formula, I'm going to square both of those. I'm going to square my component form. So that's v1 and v2, so that's going to give me 8 squared plus -2 squared. And I should really put this in parentheses. And that's going to give me 64 plus 4. And so the magnitude of v is 68. And I hope that this helps.